Alright, on this coupon we had a detection with our initial detection scans, but there's something located right here. And this is one that's probably best seen with the 60 also, but we'll also see what it looks like with the 45 and the 70. But let's start with the 60. So we've recalled our 60-degree setup. We have a 2-inch screen range. That gives us a 1-inch deep screen. OD surface, 1/2 inch deep at the 5th major division, 1 inch deep, or the OD surface at the 10th major division. We've gone ahead and set this up for reading boxes of sound path, surface distance, and depth. And we've told it the material thickness of this coupon, 505 thousandths. And let's take a look at our cal on the cal block. We've recalled our cal already, so we're checking our cal. Recall the cal, check the cal. 1 is near 1. 2 is near 2. 300 deep side drill hole is near 300 deep. And the 4 is near 4 on the screen. And it's about 50% screen height. I think I could add 1 more dB because this is about a 1/2 inch thick. I don't have a 500 hole. I'm going to add 1 more dB. And I'm going to enable my reference dB. And let's go have a look at this. So this is one where the flaw is on that side, but let's take a look at this from the other side first and see what we can see. This signal here, that's a signal coming off of the root. That stays there pretty much everywhere. But when we go by the flaw, we have this come up. And what we have here is HAZ cracking on the other side of the root. You know, the sound is coming out of the transducer, it's hitting the root, and then beyond the root. Over here we're looking this way. Hitting the root, and then beyond the root there's some HAZ cracking. And when we go by the flaw, we'll see that all of this coming up here when we scan by it. Let's push up on it. And when we push up on it, we can see those indications coming up quite a bit better. Let's try this from the other side. It's actually flawed on this side. Wow, that's really loud. And if I push up on it, I can walk over the top of a tip, and that's really loud. Normally crack tips are not that loud. Okay, there's another tip further on this end of the flaw. So I think that might be the deepest spot over there. But if I walk these cracks to the ID, you know, there's a lot of different peaks to that, so I'm getting the impression that this is not just one crack going through the part, it's a whole bunch of branched cracks, and there's a lot of different places at different distances to hit on it. And let's go ahead and see if we can plot to this deepest point. So I want to walk up the face of all these branching cracks. Find the last one where I go over the top. Could be there. Could be here. Let's say it's right here. I'm going to freeze that and we'll take some data for plotting. The screen is frozen. I'm going to measure the distance from the index point to the weld toe, and that's 650. Going to make a note of that, and we have our other numbers up here for plotting. Alright, let's go ahead and plot this. Alright, here we are on our TNC. Let's see if we can do some plotting on this. And when we were hitting what looked like the deepest point, we were 650 thousandths from the index point of the search unit to the weld toe. So let's find that 650 about there. And our surface distance from that point was 667. So that goes to about there. And our depth to the flaw was 385. That's going to be to right about there. And let's see, our sound path distance was 770. Let's get our index point right on that spot. I want this line to be parallel with the outside surface. And sound path is 770. This is our 45 line, 60, 70. Okay. 250, 500, 750, and we want to be at 770. So that's going to be right about there. So it plots up just about right. So there's some ID connected cracks here. And that's got a lot of branches to it. It's not just one single crack. And you know, an important number for this would be, what's the flaw height? That would be the thickness minus the depth to the tip. So 505 minus the depth to the tip, 385, is 120. So the flaw height is 120. And what we have is HAZ cracks. All right? Okay, thanks a lot. All right, so we can get the big picture of everything. We looked at it in detail with the 60. Let's look at this with the 45 and the 70 as well. Let's go to the 70 next. Alright, so we've got our 70 all set up. Let's take a look at this. So the flaw is on the other side. It's an HAZ crack. Let's look at it from this side. This is our root signal. As I scan into the flaw, that comes up on the other side of the root. There's the root. This is our cracking signal on the other side of the root. I'm going to see if I can walk over the top of that. It's pretty hard to do. I can detect it pretty well from this side, though. Let's try that from the other side, from the flawed side. And as I scan by it, that detects that very well. It's a little bit more difficult to do the flaw height sizing with the 70, I think. But the detection looks fine. Again, that's got a lot of branches and spurs and facets to it. It's not just to one single crack. Looks like it's got a lot of branching cracks on it, because there's a lot of different places for it to reflect off of that. All right, let's try the 45. Okay, so we're ready to go with our 45. And let's start from the, this is the flawed side, let's start from the unflawed side. That weld crown gets in the way. Maybe it will on this side too. Let's try here. So I think we're picking it up. We're picking up the flaw here, but we can't really pick up on it. The weld crown gets in the way, I think. But we are seeing it. It does look similar to the way it looked with the 60.